Okay, in this section 8-8, we're covering vectors in 3D space. And so, first of all, for those of you who are not familiar with the three-dimensional coordinate plane, you've got an x-axis, positive and negative side. You've got a y-axis, positive and negative side. And you also have a third axis for a third dimension, the z-axis. Up is positive on the z-axis, down is negative on the z-axis. So you would plot points with the first one as the x-coordinate, the second one is the y-coordinate, and the third one is actually the z-coordinate. So now, with this three-axis system, you can plot points in space. All right? And so, for a vector in a 3D space, all you have to do is just add that third component to it. Right? So here's what it would look like in component form, and here's what it would look like in linear combination form. Okay? And so, like I say, there's just a third component to the vector. Okay? So what are the rules for vectors in space? Two vectors are equal if and only if their corresponding components are equal. The magnitude would be calculated the same way, except you just have to add the third component squared underneath that square root in order to get the magnitude of the vector. Unit vector, same thing, it's the vector divided by its magnitude. Sum of two vectors, same thing, add the corresponding component parts to it for vector addition. Scalar, same thing, multiply each one of the components by the constant. Dot product, instead of adding two components, the product of two components together, it's the product of all three. And even the angle between the two vectors is actually the same formula. It's just the dot product divided by the product of the magnitudes. So that formula for the angle between two vectors in space is actually the same. So all of the properties and everything for vectors in space is really the same, except you just have that one additional component or dimension to deal with. All right? Other than that, it's pretty much the same. Okay, so what are we going to be asked to do? Let's see if we can find the magnitude of a 3D vector. Well, the magnitude would be calculated the same way it typically would, except you just have one more component to deal with. So that would be 1 squared plus negative 2 squared plus 4 squared. So you take into account all the components. That would be equal to, simplifying it down, 1 plus 4 plus 16. Okay. And that would be equal to the square root of 21. Which can't be simplified any further than that. If you wanted to turn it into a decimal just to see what the decimal was, you could do that, but that's probably the answer that you're going to see. Remember, 4 times 4 is 16, and 5 times 5 is 25, so it's somewhere between 4 and 5. All right. Dot product, really same idea. I will now go through and take all these components and multiply them together, and we'll say U, the dot product of U and V is going to be equal to negative 1 times 0, that's 0. 4 times negative 6, that's negative 24. And 3 times 5, that's 15. And we have negative 9. Then likewise, we can go through and find the angle between two vectors in space by using that formula. It's going to be the cosine of the angle, okay, is equal to the dot product on top. So let's get that first. So the dot product, 4 times 3 is 12. 5 times 1 is 5. Negative 1 times 2 is negative 2. That's the numerator. And the denominator is going to be the magnitude, the product of the magnitudes of each one of them. So the magnitude of the first one now is going to be 3 squared plus 1 squared plus negative 1 squared. And then that's going to be times the square root of, let's see, 4 squared plus 5 squared plus 2 squared. All right. So on top, that would turn out to be 15. Oh. And on the bottom, we would have square root of 11 times square root of 45. All right, so that's 9, 10 and 11, 25, 45. Okay, yeah, so we're in good shape there. And so now we know that I can actually take the inverse cosine of both sides, and we now have the angle is equal to the inverse cosine of 15 over square root of 11 times the square root of 15. All right, here's where our calculator comes in and allows us to finish it. Let's see. All right, so we'll go inverse cosine of 15 over square root of 11 times square root of 15. And I'm getting undefined because, remember, I need this to be in degrees. And once that happens, that should help. I must have made another mistake somewhere. Oh, I did. It's not 15. It's 45. But we need to make sure that we're in degrees anyway. So we need to change that to 45. So I copied that down wrong. And I'm going to change that here. And once again, we are in degrees, so double check that because that'll throw you off too if you're not. And so 47.61 is the angle. 47.61 degrees. All right. That's it.